Second Navigating Drought in the Missouri River Basin webinar. My name is Ganna Rush. I'm with High Plains Regional Climate Center. Presenters today will provide the region with timely information on current and developing drought conditions and developing hydrologic conditions, and also discuss observed impacts and other relevant updates from across the region. Additionally, these webinars will feature relevant drought research and findings from partners across the basin. Speakers may also discuss the impacts of these conditions on topics such as water resources, wildfires, recreation, and ecosystems. Webinars and recording and other supporting materials will be posted on the drought.gov website later this week. And if you're signed up from emails from NIDIS, you'll receive notifications when those are available. Note, after today's webinar, you'll have an opportunity to provide feedback that will help us improve this webinar series. Please take a moment to tell us what you think. The speakers we have today doing seasonal and current drought conditions will be Matthew Sittel. Doing the Missouri River hydrologic conditions and outlook will be List Holt. Doing agricultural impacts will be Ryan Larsen. And doing drought extremes and rangeland management will be David Hoover. Before we begin the presentations, we want to highlight the partners who make this webinar series possible. These partners are instrumental in the development of these webinars, and the products and services they provide are pivotal, staying updated on conditions across the basin. Visit the website in the chat box for more information. Thanks again. NIDIS was established in 2006 by public law with a mission of improving the nation's capacity to proactively manage drought-related risk. NIDIS provides the best information and resources available to assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. NIDIS maintains the foundation of a national drought early warning system through the development of regional DEWs, where networks of partners and interested and affected parties share information and actions that help communities cope with drought. Although the ultimate goal is a national early warning system, we recognize that impacts and early warning information differ among regions. The regional DEWs have many of the same basic features, but each has distinct aspects to reflect the needs of its region. And NIDIS also enables the nation to move from reactive to more proactive approach to managing drought risk and impacts. The High Plains Regional Climate Center is one of 6 regional climate centers managed by the National Centers for Environmental Information, covering the entire United States. The 6-state region for the High Plains Regional Climate Center covers Colorado, Kansas, Nebraska, North Dakota, South Dakota, and Wyoming. Our goal is to increase the use and availability of climate data and information. We accomplish this by providing climate services, developing climate data and information products, and engaging our stakeholders. To facilitate our early warning system, more precipitation observations are needed. We encourage you to join COCORAS, the Community Collaborative Rain, Hail, and Snow Network. COCORAS is a unique, nonprofit, community-based network of volunteers of all ages and backgrounds who work together to measure and map rain, hail, and snow and report conditions. Observation by COCORAS observers of precipitation events and the lack of precipitation are important ways to capture and improve our understanding of weather. Become a volunteer or learn more about COCORAS, or visit the website or contact your state coordinator. Links will be provided in the chat. And understanding how drought impacts you is important for many drought assessment at the state, regional, and national levels. The National Drought Mitigation Center Condition Monitoring Observer Reports, or CMOR system, is a great way to submit the impacts you're experiencing from too much or too little water. Becoming a regular observer makes this information more accessible to those who assess drought in your state. Links to learn more and view reports will be in the chat. And if you come across this webinar in any other way other than a direct email to you and want to receive the recording and other pertinent information for the Missouri River Basin DEWs, please follow the link in the chat to sign up. You might also be interested in NIDIS's biweekly Dry Times newsletter or Tribal Engagement newsletter. Thank you to all of our speakers who will be presenting today. We'll provide all speaker contact information and presentations after the webinar. Please mark your calendars for our next webinar on November 20th, 2025 at 11 a.m. Central. NIDIS will be changing platforms for this webinar. Official registration link will be made available as soon as possible. After today's webinar, you have an opportunity to provide feedback that will help us improve this webinar series. Please take a moment to tell us what you think. Thank you for your time and have a wonderful day. And with that, I'm going to stop sharing for a second so I can bring up Matt's slides for him. There we go.
All right, I want to make sure everybody can hear me. Are we good?
Yep.
All righty.
Matt.
All righty. Well, hey, good morning to everybody. I'm Matthew Sittel, Assistant State Climatologist. I'm here at Kansas State University in Manhattan, and I am pleased to be sharing with you an update on drought conditions as they are currently in the Missouri River Basin. Before we do that, I want to take a bit of a step backward. If we go to the next slide, let's take a look at temperature anomalies from the summer, and that's June, July, and August, those 3 months together. And you'll find there is a color table in the lower left. Climate divisions here that you see that are in the white, they're within 1 degree of normal for those 3 months combined. Areas outside of that, for example, eastern Montana, 1 to 3 degrees above normal, and even into western Montana, 3 to 5 degrees above normal. If we take all of the territory that covers the Missouri River Basin, the average temperature anomaly for summer was plus 1.3 degrees Fahrenheit, which ended up ranking collectively as the 36th warmest meteorological summer out of 131 years dating back to 1895. Now, where do we stand so far in the month of September? If we take a look at our next slide, we will see what the departure from normal temperatures is, courtesy of our friends at HBRCC for providing this graphic. And you'll see for most of the Missouri River Basin, we are running above normal for temperatures so far in the month of September. The most notable positive anomalies are occurring along the U.S.-Canadian border in North Dakota into eastern Montana. In fact, a couple of communities, Williston, North Dakota, Cutbank, Montana, so far are running over 5 degrees above normal for the month of September. There are a few isolated areas in the green that are running slightly below normal, including parts of here in Kansas as well as in Nebraska. Now let's take a look at precipitation, and I'm going to go to our next slide. We'll start again by looking at June, July, and August for precipitation. Again, we've got our climate divisions displayed here. And if you'll take a look, we have a different color table at the bottom now. Those shaded in green, those are above normal totals for the summer. And the ones that are in the shades of brown, that's below normal. And you'll note that the Missouri River Basin is predominantly above normal. We see green and most of our divisions, with the exception of northern North Dakota, and again, just along the Rockies in western Montana into parts of Wyoming. And now if we take, I'm sorry, I should mention that the collective average anomaly plus 1.11 inches for the summer. This ranks as the 25th wettest summer in the last 131 years. Now, where do we stand in the month of September? We'll go to our next slide. And before we show where we are now, I wanted to at least point out what normal precipitation looks like for the month of September. September is not one of the wettest months of the year. We're transitioning from the wetter months in the summer into the drier winter period. You can see along in Montana, North Dakota, those average precipitation totals run generally from 1 to 2 inches. It's a little bit higher in parts of Kansas, and the highest numbers we see running from 3 to 4 inches in parts of Missouri. Now, we'll go to our next slide, and we will see where we stand right now in the month of September through the first 24 days. Again, HBRCC, thank you for providing the graphics for the presentation here. What do we see? Well, we see some red areas along Montana, but we've got to remember that when we see a red area here that's 2 to 5%, we're only talking on average 1 inch of precipitation for September. So 2 to 5 inches is really less than an inch below normal. So this is not a situation where we're seeing drought conditions rapidly beginning because of this lack of precipitation. I think the thing that stands out the most to me is the central plains from Kansas up to South Dakota that we see above normal precipitation, and especially there's a bullseye there in central South Dakota. And if you'll hit the next slide there, Gannon, I wanted to point out one community in particular who is the most above normal. that I could find. Mobridge, South Dakota has had 6.48 inches of rain so far in September. Believe it or not, that is a record for Mobridge, and their data goes back over 100 years. Wettest September on record by nearly 2 inches. And they've still got 6 more days in the month to potentially perhaps get some more precipitation, but very unusual. Most of that fell between the 13th and the 19th of the month of September. So there have been some higher precipitation totals, especially down here in Kansas as well. We have a couple of locations over 13 inches of rain for the month of September. Collectively, that's good news, because when we look at the drought monitor, this is the latest release of the U.S. drought monitor map from this morning, and you'll see, if we go back ahead the slide there, Gannon, we will take a look at our U.S. drought monitor map, and we see, hey, the whole state of North Dakota, for example, is completely drought free. The worst areas we have are kind of along the edges there, along the Rocky Mountain spine there in western Montana, and most of Missouri, or I should say at least the southern part of Missouri that was in our Missouri River Basin. Drought conditions have developed there here in the last month or so, because of all the heavy rain that you saw in Kansas and Nebraska didn't really work its way into Missouri to give them precipitation. So there are some areas of D2 down there in south central Missouri. And if you'll hit the slide one more time there, Gannon, we'll take a look at collectively, because I know there's a table up there that's kind of hard to read. 62% of the Missouri River Basin is currently drought free. That number is actually 4% higher than it was last week. So we are trending in the right direction. And fortunately, we've only got 1% of this basin in D3. Again, you can see in western Colorado as well as western Montana. Those are the only areas that we're seeing extreme drought conditions there. So that's really good news. If we take a look at how drought monitor conditions have changed in the last 13 weeks on the next slide there, we will see that what stands out here, green. Green is good news, because that means drought conditions have improved since 3 months ago. And 3 months ago for this map is June 24th. We're comparing that between that date and September 23rd, the most recent release that we saw on the last slide. You do see some worsening conditions again in the state of Missouri, and also in parts of Montana, Wyoming, and Colorado. So overall, it's mostly good news. And the fact that we've seen improving drought conditions and we've had wetter than normal conditions means that wildfires, on the next slide, have really been not a problem, at least lately. This is a map from the Canadian Wildland Fire Information System. I chose this map because really the biggest problem with wildfires is in Canada right now. You can see there is a table to the right there, and the color of the symbols there refers to the status of the fires. The purple one, that looks to be the worst conditions, or the blue ones are under control, out of control, and then the red ones, those are the worst of all. And we see a number of dots across northern Manitoba, Saskatchewan, into to northern Alberta. Collectively, I was just taking a look at the statistics. This is the second worst wildfire season in Canada. The worst one was only 2 years ago in 2023. So there's been a run here lately of severe wildfire conditions, and perhaps you've noticed smoke that has been ejected from these wildfires into the United States. I know in the month of July, the Northeast was dealing with a lot of problems with wildfire smoke. But right now, U.S. is looking really good. It's Canada where the problems are. And if we look at the next slide, I thought I would take a moment to show you another product that you may not be as familiar with. On the same website with the U.S. Drought Monitor, there's also called the North American Drought Monitor. It's updated only once per month, and this data are valid through the end of August, so it does not reflect any precipitation that may have fallen in the prairie provinces since August 31st. But note the big difference here. You know, North Dakota, we just saw, had no drought conditions, drought-free for the entire state. Cross the border and go into southern Manitoba, look how quickly, as you go north, drought conditions worsen. And there's a lot of D3 areas. And not surprisingly, the D3 areas and D2 areas across northern Manitoba, northern Saskatchewan correspond to those areas that we saw on the last slide where the wildfire conditions are widespread. So this is kind of what we would expect in a condition when we have dry conditions like this. But thankfully, Missouri River Basin collectively looking really good, and wildfires are not an issue right now. One more slide I wanted to show you before we finish up here, and that is a newer product that you may not be familiar with. Its acronym is EDDI. It stands for the Evaporative drought demand index. So the way to think about this is from a color standpoint, if you see areas in yellow and orange, those are areas where drought conditions are more likely to develop because there is a lack of moisture. Take a look at across South Dakota, Nebraska, Kansas. We see blue colors there. Those are areas where it's very wet right now, as we've seen in some of our previous slides. So with that wetness there, there's not a potential in the short term for drought conditions to develop. So anywhere you see blue, which is a lot of our basin, that's really good news. This is what we want to see. We want to see good conditions here. So in summary, we'll go to our last slide here and talk just a little bit, reviewing what we've shown so far. Warmer than wetter conditions for the summer. We're now almost through the month of September. We've got 6 more days to go. Warm and generally wet September for most areas, which again, wet conditions are good news for us. So that's led to improved drought conditions in most of the basin. And there's a limited risk for immediate drought development, as we saw on the EDI map, and also a limited risk for U.S. wildfire expansion, at least in the short term, that things are still looking good here. That is my last slide. My email is down in the corner. If you have any questions or want to reach out, feel free to do so. I will throw it back to Gannon now. Thank you for your time.
Thanks, Matt. I'm going to stop sharing here. We're going to turn it over to Lisa. Sorry, I completely just miswrote your name on my slides. So we're going to turn it over to Lisa to give us the Missouri River hydrologic conditions and outlook.
Thanks, Gannon. No worries. So I am Lisa Holts, the lead hydrologist here at the Missouri Basin River Forecast Center. Jumping right into the slides here, let's go ahead and talk about conditions across the basin as a whole. The 28-day average streamflow conditions show new record lows in West Central Montana and Central Wyoming. Normal conditions exist in the Missouri River Basin portion of Colorado, with normal to much above normal conditions in the Dakotas and Nebraska, while Kansas is experiencing normal stream flows. Looking to the right, after trying to recover some in late July, the Missouri Basin as a whole has fallen right back to sitting between normal and below normal stream flow when compared to the 28-day average runoff. Unfortunately, that is largely where we've actually been sitting over the past year. Now, breaking things down by the states, state duration hydrographs for the 28-day average runoff for Montana and Wyoming are showing the same pattern as the basin overall, which is much below normal. It has been riding the line between normal and below normal for about a year before sharply dropping off to the below to much below average at the beginning of June. This is due to the less than normal spring mountain runoff combined with the lack of rainfall this spring and summer in that area. Now looking into Colorado, it shows much of the same picture. Here, stream flow dropped in May and remained much below average since. Overall, for all 3 states, conditions are worse than they were this time last year. I'll also note that over the past 3 months, the western portion of these states have actually been much drier than the eastern portions that fall within the Missouri River Basin. Looking into the Dakotas, though, the picture is much brighter. North and South Dakota show as a whole, runoff has fluctuated in the normal to much above normal range over the past year and a half. After drying out some this past winter, they have rebounded well this summer, staying in the above to much above normal category due to the regular significant rainfall events that they have been experiencing in this area. And finally, taking a look at Nebraska and Kansas, since this time last year, Nebraska has flirted with below normal, but with the regular thunderstorm activity this summer, has caused a large rebound and now experiencing normal to above normal 28-day average runoff. Kansas, on the other hand, has largely remained in the normal category for the past 2 years, pushing into the above normal category just this past several months. Taking a look at the drought monitor once again here, with the spring mountain runoff being below normal and after having a dry summer, moderate to isolated severe to extreme drought conditions do exist along the western border of the Missouri River Basin in Montana, Wyoming, and Colorado. Southern South Dakota, and western Nebraska are still experiencing moderate drought with isolated severe to drought conditions in the Nebraska panhandle. In the lower basin, northeast Kansas into most of Missouri is experiencing abnormally dry to moderate drought conditions due to the inconsistent rainfall over the past several months. With that said, drought conditions are largely unchanged over the past month. Currently, around 20% of the Missouri River Basin remains in D1 through D4 drought, while 18% was in drought in late August. Despite minimal flooding activity this summer, episodic flooding has occurred in the past month on the Bad, James, and Big Sioux rivers in South Dakota, the Republican River in Nebraska and Kansas, and the Smoky Hill River in Kansas, including one record flood along the Salt Creek in Nebraska. In Kansas. Sorry, I had that wrong. This flooding has caused is caused by a series of strong thunderstorm activity leading to very heavy rains in this area. Looking at the image presented here, it depicts the current conditions and flooding across the Missouri Basin. Elevated river levels continue to be forecast for the James Basin in South Dakota. Circled are the areas that have experienced flooding over the past month. Our office issues 90-day river flood outlooks near the end of each month. The most recent 90-day outlook was run this past week and covers the 3-month period from late September through late December. The map I am showing on this slide depicts the results of the river outlook for the 400 plus locations we monitor across the basin. Flood risk is denoted by the color of the particular river station, with green meaning less than 50% chance of flooding, orange being greater than a 50% chance for minor flooding, red for moderate, and purple for major flooding. Our most recent river outlook indicates that almost no areas are expected to have a greater than 50-50 chance of seeing flooding through late December. We are highlighting the James River in South Dakota as river levels are currently exceeding flood stage. Overall, when compared to historical, though, we have a near normal flood risk across the basin. Risk for flooding between now and late December is dependent upon timing and location of any significant rainfall events. Thunderstorm activity in the lower basin this fall will continue to drive flooding in the area. Most flooding that we've seen over the past several months has come from very heavy local rainfall. It is likely flooding that we will see over the next few months would also be due to this, but will transition to larger scale weather events causing longer duration precipitation events that could lead to flooding. In summary, I will point out that the summer was dry, mostly in the western Montana, Wyoming, and Colorado areas, but near to above normal precipitation fell to the east. This has led to stream flow for the past month to be much below normal in Montana, Wyoming, and Colorado, primarily driven by the western portion of those states, though, while the stream flow further to the east was normal to above normal. There has been recent flooding across Kansas, Nebraska, and South Dakota. And finally, flood potential over the next 3 months is minimal, with the exception of eastern South Dakota due to the elevated river conditions currently being experienced in the area. Thank you, and that concludes the NWS hydrologic conditions and outlook.
Thanks, Lisa. We're going to turn it over now to Ryan Larsen with the Army Corps of Engineers, who I had written down doing ag impacts, but that doesn't make sense when he's with the Corps of Engineers. So he's going to tell us about reservoir conditions and impacts.
Hey, Ryan, we cannot hear you yet. You might still be muted.
Can you hear me now?
Can hear you now. Thank you. Go ahead.
All right. Perfect. My name is Ryan Larsen. I am the Reservoir Regulation Team Lead for Missouri River Basin Water Management. I'm going to be going over the Missouri River Main Stem Reservoir System status and kind of how we're seeing the runoff coming into the system, as well as the impacts to the reservoirs. So for starters, just to familiarize with the main stem system, our office is tasked with operating 6 main stem reservoirs on the Missouri River, starting with Fort Peck in Montana, Garrison in North Dakota, Oahe, then Big Bend, Fort Randall, and Gavins Point in South Dakota. We operate these 6 projects as a system in support of 8 authorized purposes, and we do have a wide area of responsibility. So the Missouri River Basin is roughly 529,000 square miles. About a third of that is channelized. So starting at Sioux City, Iowa, down to St. Louis, Missouri, all of that portion of the river has been channelized with the Bank Stabilization Navigation Project. 2/3 of the basin is regulated, with about half of the regulation coming from the main stem reservoirs upstream of Gavins Point Dam. The other 16% or so is regulated by the tributary projects, but we still have about 165,000 square miles of unregulated drainage area below the main stem system. So putting our reservoirs into kind of a little bit of context here about how large they are, we do have the largest reservoir storage system in North America with a total capacity of about 72 million acre feet. Garrison, Oahe, and Fort Peck are the 3rd, 4th, and largest storage reservoirs in the federal inventory, and they are the 3 largest reservoirs in the Corps of Engineers reservoir inventory. And we roughly have about 3 times as much storage as we do to annual runoff. So the upper 3 reservoirs, as I mentioned, are what we refer to as the big 3, and they really drive the system. So we have about 88%, close to 90% of total storage in those upper 3 projects. They contain 85% of the total flood control and 96% of that carryover multiple use zone, which is important because that is the storage that we utilize during long-term droughts. We start drafting those big 3 reservoirs down. We still support those 8 authorized purposes, but we start implementing some drought conservation measures, which is where we're at right now. The lower 3 projects really don't have much in terms of total system storage. In particular, Big Bend and Gavins Point really are just hydropower peaking and re-regulation projects, so they don't fluctuate their pools very much. Fort Randall does provide a little bit of winter storage and hydropower boost and some local flood control. But again, the big 3, the upper 3, are the ones that are going to provide all the flood control or most of the flood control, and they really are the ones that are affected during long-term droughts. So switching gears here, we kind of heard about all of the meteorological and climatological data. How does that translate to runoff? So this graphic shows our period of record runoff above Sioux City, Iowa, with the long-term droughts highlighted in the yellow bars. The 2025 calendar year forecast is highlighted in red there. You'll also notice some black lines on there. We put up some statistical bars here to kind of put in perspective of how dry or wet a particular year is. And highlighting here this lower quartile one, that line just indicates that there's about 25% of the runoff years below that line, 75% above that line. Switching gears to the upper quartile, you've got 25% above, 75% below. So that 2025 calendar year runoff forecast is hovering right around that lower quartile statistical bar. Breaking off that annual runoff into average monthly runoff above Sioux City, Iowa, you can see that we really had below average runoff in the springtime. Typically when we see that plain snowpack coming off, we had below average plain snow, so we had below average spring runoff. May was a little bit of an anomaly, and that was mostly due to the mountain snowpack that was near average, coming off a little bit earlier. So instead of seeing that runoff spread out between May, June, July, we had a bulk of that coming in at the end of May, which is why then you see in June, we really tail off on the runoff coming into the system above Sioux City, Iowa, is because most of that mountain snowpack had already entered the river system and was making its way downstream into the reservoirs. Looking further out into the fall, into the early winter time frame, we're forecasting just below normal runoff conditions, but we don't typically see a lot of runoff in the fall either. So for the calendar year runoff forecast, we're hovering right around 74% of average. This graphic shows our main stem system storage. So if we were to take all 6 of our main stem reservoirs and make one giant reservoir out of it, and then split them out into the different storage zones, this kind of highlights where we're sitting in terms of system storage, as well as comparing it to all of our system storage checks that I'll get into a little bit later. But we really didn't have much pickup in terms of system storage this year. And we're forecasted to draft even further down into this carryover multiple use zone, which the top of it is the green line and the bottom of it is not shown on this graphic. But we're going to continue drafting the reservoirs further down, which is going to further exacerbate our drought conservation measures. So breaking those that system storage out into individual reservoirs, we kind of highlight the big three as well as Fort Randall here. At Fort Peck, we're right around 11 feet below the base of the flood control zone. And again, typically we like to kind of start at the base of flood control, store the water, and then meter that out with releases supporting the authorized purposes, ending back at that base of flood control. But we start drafting down into this carryover multiple use zone during these long-term droughts is what you're seeing with these reservoir breakouts here. Garrison, about 5.5 feet below the base of flood control zone. Oahe, about 7 feet. Fort Randall is actually 4.7 feet above the base of flood control, but that is about where it's supposed to be this time of year. We will actually start drafting that reservoir down. We draw that reservoir down during the fall so that we can refill that over the wintertime. Gives us a little bit of a hydropower bump over the wintertime. I mentioned those master manual curves, those system storage checks. These are the tables that are in our master manual and the 3 system storage checks that we have throughout the year. So March 15th, we'll set the service level for navigation flow support for the first half of the season. The July 1st system storage check will set the navigation flow support for the second half, as well as the navigation season length. And then our last check on September 1st will set the winter release for Gavin's Point. Based on the July 1st system storage check, we are operating at 4,500 CFS below full service for navigation and flow support. We will have a full 8-month navigation flow support season. And now, based off of our September 1st system storage check, we are continuing to draft those reservoirs down. And so we will be at the average winter release rate of 12,000 CFS, which is the minimum winter release rate from Gavin's Point. So summarizing some key points, the reservoirs are in good condition for any flood control that we need to have. So we have all 16.3 million acre feet of flood control space available, plus an additional 5.4 million acre feet as we've drawn the reservoirs down into the carryover multiple use zone. I just mentioned that our navigation service level, based on that July 1st storage check, is 4,500 CFS below full service. We're going to have a full navigation flow support season. That means that we're going to end the flow support on December 1st at the mouth of the Missouri River. We'll start ratcheting down releases on or about November 22nd, and we'll be reducing releases down to that minimum winter release rate of 12,000 CFS, again, based on that September 1st storage check. And that's all I have.
Thank you, Ryan. While we get switched over, our next presenter is David Hoover from the USDA, and he's going to talk about drought, climate extremes, and rangeland management.
Thank you, Gannon. Can you hear me okay?
Yep.
All right. Great. Well, thanks. Yeah, so I'm Dave Hoover. I'm with the USDA ARS, based out of Fort Collins, Colorado. I'm a research ecologist. And today I'm going to be talking about some research I'm involved with that focus on building drought resilience through adaptive rangeland management. So if we think about the extent of the Missouri River Basin, if anyone's flown over this region, you know that quite a lot of this land is dedicated towards rangeland or cropland use. So you see center pivots from the airplane, you see a lot of extent prairie. In fact, most of this area is rangeland, so about 50% is range, and then about 30% is cropland. And so if we think about the difference in managing these systems in the context of extreme weather, we have a bunch of tools at our disposal in cropland. So we have environmental monitoring, so you can use satellite data, ground-based sensors, some of the tools presented here by the other speakers. And then there's management tools. So this is how farmers can adapt to some of these changing conditions. So in terms of adding irrigation, if there's drought conditions, changing seeds, fertilizing, different timing of harvesting, So there's different ways to adapt our cropping systems to climate extremes. In rangelands, however, we lack a lot of these tools. We are in mostly native prairie ecosystems. And so a lot of what the management is looking at our environmental conditions, how our plants are responding, and then the main management tool is changing the amount of animals we have in the landscape and their distribution. And so there's a lot of important rangeland ecosystem services. So one primary one is forage production, so that feeds the cattle or other livestock. There's a lot of biodiversity in terms of flora and fauna. The vegetation helps to prevent both water and wind erosion. And there's a lot of important soil health characteristics. So what are the challenges that many of these rangeland managers face? Well, in terms of climate, temporal variability range is huge. So this is showing annual precipitation over 1940 to 2020. And so you can see there's just a huge amount of variability year to year. Then there's also a lot of spatial heterogeneity. So we can have variability across the landscape in terms of rainfall. There's also topoedaphic, which is saying that how the soils and the topography varies. And then there's big changes in the plant community. So when you're driving through the rangeland, grassland, it looks like there's not a lot of complexity, but there's highly complex systems, highly variable systems, and it makes it very challenging to manage. So I'm going to be talking today about one research site I'm involved in the Central Plains Experimental Range. This is shortgrass steppe located in northeast Colorado. And so this station has been around since the 1930s. And so there's been all sorts of experiments, observations conducted over this period. So we have a huge amount of data we can draw on. And then also a big part, in addition to publishing these data, is presenting these data to stakeholders. And so you can see throughout time, there's been this model of talking to stakeholders about what our research findings are. But one of the problems is that this doesn't allow as much of a two-way feedback between the stakeholders and the scientists. So starting in 2013, we've created a new experiment called the Collaborative Adaptive Rangeland Management Study. And so the goal of this is to pass on the land to future generations ecologically and economically. So this group consists of stakeholders. So these are local ranchers, federal agencies, nonprofits, and scientists. And the scientists come from a variety of disciplines. So there's economists, there's animal scientists, ecologists, social scientists, and been working together for over a decade now to try to understand how we can better adapt this system and build resilience. So for the first 10 years, the study used rotational grazing. So the idea is we had 10 pastures in yellow that had traditional grazing management, and that had a set amount of livestock. And then the blue pastures, we took all the animals and moved it in one giant herd and rotated through the other 10 pastures. And the idea was that they wanted to rotate the animals to achieve 4 objectives. So profitable ranching, increasing vegetation diversity, improving wildlife, and then also improving social learning. And so as a scientist on the project, our role is focused primarily on collecting the data. So these range from environmental sensors, remote sensing, livestock monitoring, and then developing decision support tools. So one of the roles I have is running our ground-based environmental sensor network. And so this network is embedded in our experimental design. So this includes precipitation gauges, soil moisture probes, eddy covariance towers that measure the movement of carbon, water, and energy between the land and the atmosphere, and micro watersheds that monitor runoff at the small hectare scale. And so I'm going to focus primarily on our rainfall and soil moisture because these are generally our most critical variables for managing the range. So the top graph is showing our rainfall over the course of a period, and then the bottom part is showing our soil moisture. And so what this is, this heat map is what it's really showing is this is the surface of the soil profile, and this is going deep into the soil profile, and this is how it varies through time. The colors are representing whether there's wet periods, so the cooler colors are showing wet moisture, and then the warmer colors are showing when there's dry periods. And so what we can do is use that information and the context of where our plants are rooted to understand when there's a lot of water available and when we may be experiencing water stress. So the stakeholders at the beginning of this experiment came up with hypothesized management trade-offs between our traditional rangeland management on the left and our collaborative rotational management on the right. So one of the ones that's important is drought resilience. So they hypothesized that there might be a trade-off with improving drought resilience with beef production. So by rotating the cattle so that we have more options with our forage, it might reduce a little bit of the beef animal production. So this area of the country was at the edge of the 1930s Dust Bowl. In fact, our station is there because it was land abandoned during the Dust Bowl. So it's very present in the minds of the ranchers that persisted since then. They're fifth generation ranchers. And they came up with these drought management plans that use adaptive rotation to improve flexibility, use rested pastures for grass banking, and then had these climate triggers based on our ground-based environmental monitoring. And so I'll quickly show an example of how we did that. So throughout the summer, we looked at what the cumulative rain was to date. And based on that, if it's 75 to 85% of average and the soil type that it's on, we would cause triggers to rotate the cattle. And then we would do that every 2 weeks. And based on these thresholds and the vegetation, we would use that to move the animals around the landscape. And the other bit of information we supplied the ranchers were different precipitation and soil moisture data. So this is some maps and fuel gauges that we worked with them to come up with good ways of visualizing what our moisture availability is out there and how it relates to the historic context. So this is an example of the rain that we had in 2020 and 2022, which were drought years for us. So the dotted black line is showing our cumulative precipitation over time on average, and drought being 75% of normal, and that was what the stakeholders defined as drought. And so as you can see in 2020, we started just a little bit above the drought line, but then when we got to the summertime, we crossed into severe drought. 2022, we started below drought the entire time, and that was a critical period we found. And it was largely because that's when our plants green up. And so this is showing what soil moisture looks like in a normal year. So again, like the figure I showed before, this is the top of the soil moisture, the soil profile, and this is going into the soil profile. This is through time. And so what you can see is that we usually have dry springs and winters, and then we get our water comes around March and April, and it wets the surface, and then it can get saturated, and then we dry out into the summertime. Now in our 2020 drought year, we got a lot of that early rain that helped to wet up the soil, but then we didn't have any later in the season. And in 2022, we had no moisture early on and just a few late summer rains. And the interesting thing was that we had the same amount of rain in both 2020 and 2022, but our forage was much lower in 22 because the rain was very delayed. And so coming to this year, we used some of that knowledge and looked at the spring conditions. So we were a bit below average. So this blue line is showing what our current moisture is. And so we had right around April, when we meet with our stakeholders, we were below average and trending into drought. And there was a lot of concern that we were going to go into a rough year. So we were creating plans for how we were going to respond in terms of our livestock numbers and their distribution. And then we had a very wet May, and that got us above average. And so we didn't end up having to adjust our cattle stocking rates. But had it persisted in those drought conditions, we would have probably had to reduce our stocking rates in response. So in summary, this co-production model between the scientists and stakeholders can really help define management objectives and develop these decision support tools. Ground-based sensors are really important for informing adaptive decision-making during drought, and particularly if it's done at a scale that's really relevant for ranching. And then the next steps for our experiment is we are trying to incorporate more landscape heterogeneity into the design, and we're also changing our pastures and the way we're moving animals to try to achieve some of those objectives better. And then finally, we're redeploying our sensor network based on stakeholder input to capture more landscape heterogeneity and yeah, have better real-time data. And that's all I got. Thank you.
Thanks, David. As of right now, I don't see any questions in the chat box. That's all our speakers for today. So if you have any questions, we'll give you a minute or two here to type them in the chat box. I'm not seeing anything, so thank you to everyone who joined today, and thank you to all of our speakers. Our next webinar will be on November 20th at 11 a.m. Central, 10 a.m. Mountain Time, and we hope to see you there. Thank you and have a great day.